Here we go, preparing live stream, and we should be streaming on YouTube now. And I start recording here. Great. So welcome to this Open Security Summit session in June 2024. We have an amazing set of panelists here, crazy amount of experience on mapping and security. And we're going to be covering a lot of I think the new possibilities, especially, I think, this is definitely a topic that in the past for me was, we knew how to do it. The question was how to scale, right? So I think we now get into that point. So maybe just a quick introduction with you guys. Maybe Chris, start with you, then Tudor, and then Tariq.
Fine. So my name is Krzysztof. That's difficult to pronounce, so friends call me Chris. I work as a strategy consultant for DXE. And I think that's all. Yeah.
I'm Tudor Girba. I am the CEO of Think. At Think, we make systems explainable. So we work with both legacy systems and new systems. And in both of these situations, we employ something we call moldable development, which is a new way of programming through custom tools.
Hi, I'm Tariq. I guess I'm what they call an enterprise architect. And I try and help organizations kind of step back from the nitty-gritty of the operations of security and all the kind of things that go with that, and ask themselves, well, what is it we're trying to do? And that I think encourages better questions like, what are we trying to protect? What is the work we're trying to do? How do we make this proportionate? And those are quite important human questions. And in the past, I've done a little bit of policy work in central government around defining some of the security frameworks. And again, it's the same approach. What is it we're trying to do? And how do we make it usable? And how do we ask the important questions of how do we balance kind of costs, usability, and the enthusiasm for technology, that is security controls. That's me.
Cool. So I guess the first question to ask is that, how do we scale, right? Asking, connecting those questions, mapping that, and then, reaching out. Like, what's your sort of experience so far, and what's your thinking on that?
So do you mean? Sorry, go ahead.
No, go. Please go.
I was asking, what is it that you're asking about the scaling of the discussions around security, or the scaling of the operation of security? Which is it that you're particularly thinking about?
More in terms of the practice, right? I think this is, again, it's a practice that is like security. Like we kind of know what good looks like, right? There's a lot of good practitioners, people who've done it before, right? The problem I think is that a lot of it's a one-to-one relationship. It's like you go and do one thing, right? It's like, how do we scale that, and how you find ways to scale? Because I'm sure you tried to do scale too, right? And in fact, Tudor has a freaking whole framework that's been designed to think about that, right?
Yeah, I think I don't have a great answer, but I certainly have some observations that I've seen over the years, which is, scale brings with it a challenge, and what you can do in an organization the size of 5 or 10 people is much more difficult when you get to thousands of people, and there's a tendency then to fall back onto the application of process and procedure. This is the procedure that we're going to apply. It's the only way to sustain this thing called security at scale, is we all follow the same process and procedure. But the risk with that is that you stop thinking, and you then apply that procedure blindly. On the other hand, we're all human, and there's only a finite number of us in an organization, and we can't apply a bespoke approach to every question and challenge that arises. So it has to be in the middle somewhere. But I find that we haven't even got to that point. Lots of organizations will just default to, this is how we do it. This is the process that we apply. Is you tick this box, you fill in this form. And actually the challenge that I found is that you get a significant benefit in picking your battles and encouraging that human discussion. So you say, all right, we're going to take some half an hour out, once a week, and we're going to get together and talk as humans about what is it we're trying to do here. Why do we think this is a disproportionate or an insufficient approach to security? And that's where the real work happens, which is that human, building those relationships and understanding what it is each other are really trying to do. So that's my observation I have about scale.
I have another, because we've been conducting at DXC research around security in the last year. And one of the findings, I think it was pretty interesting one, and pretty obvious one, was that if you've got a support of the board, like a proper support, and if the board really values security, then employees have no choice. Because usually what happens is, if you are pushed by deadlines and you get a security alert, this alert is an obstacle that you have to work around, right? Because it is getting in the way of your business. It will be visible on your it will be visible in your KPIs, in your performance review and stuff like that. So you need to get past it as fast as possible. So people tend to ignore that stuff. And they use all sorts of the workaround, private computers, private pen drives, whatever, sending confidential messages to private email, because suddenly it is too difficult to use corporate environment. So we have to know and acknowledge that this stuff happens. And one of the things that that was also highlighted in the research was that it actually helps to make people aware of how dangerous the internet is for them, not for the corporate. So what would happen if all of the photos from your mobile phone would leak to the internet? What would happen if your email leaked or email credentials leaked? And when you think about it, the consequences are so far reaching for even an individual that suddenly people start wondering what they are doing. And even if they use private, let's say, unauthorized solutions, they become much more careful about them, right? Because it's tied to their personal identity. So they try to cover their personal identity properly. They do their research, they prepare, and only after that, it's not a full security solution, but it makes people aware and makes people care about this stuff. But of course, the support from the board is the most important thing.
Tudor, what's your views on this?
So I look at it, I think the human aspect of security is definitely important. And you do want to create awareness so that people know what questions to ask. So the thing is, once you ask the question, how do you get the answer? The bottleneck is the getting of the answer, not the asking of the question. Actually, no, it's the asking of the question first, but the problem is that we can't get the answers from systems. This is where, like, we fill the form, you do the thing, but nobody knows whether the system actually complies to the thing that's, the paper says it should. That's the problem. That's the thing to actually fix. And that is actually not a security-related problem. It's, in general, a problem of how do you get information out of systems. Today, most effort in software development is actually spent on getting this information out of systems, and most of this effort is actually manual today. That's the thing that we need to solve first and foremost, and then we can, of course, optimize some of this effort for security. But I don't think that security is particularly is any different than any other question we might have about the system. Yes, you will be exercising something else in the system, but nevertheless, it's really about the system. And so, for example, today we think about security as being, you would do maybe a penetration test and you assume nothing about the system. Like when you do a penetration test, how do you do it? Like you say, oh, right, this is the surface that we see or somebody sees, and then we're going to try to go through that one. But what if you do the other way around? I mean, if you really want to test, what if you actually know the system? And then with that knowledge, try to go from the outside. Then it's much more interesting, isn't it? And the effort that you spend there is going to be much more interesting, right? The more you know, the better questions you ask. The better questions you ask, the more interesting answer you're going to find. Today, we just pretend to know things about the system. The system is pretty much a black box. And so we are happy when people poke at it as if it's a black box. And then we don't know the extent to which people do it. What are the relevant questions or not for our specific system? So to me, that's the problem. And that's why we can't scale anything of meaning. So that's the first thing we have to solve.
And I think that's a really good point, right? Because and for me, the big nugget that I take from that is that question of how do we know how the system works, right? And that we should be putting technology and understanding how the system works, because or else it's all faith-based security, right? It's people telling, well, I think this works like that, right? And I really feel that that's definitely something again that Tudor been doing for a long time. But I think now with Gen AI, right? I think we have a good chance to be able to do that. And I think the big difference is that in the past, in a way, the path that you had, which for me, I've done it before, like when I do pen testing and even I build these platforms in the past, was you say, well, I need to understand that system. So I'm going to build a system to understand the system, right? So I'm going to create a framework. The problem with that is that we codify, right? That understanding, right? We codify that particular analysis of, the attack surface, right? The problem was that was very brittle, right? Because there's a lot of engineering, there's a lot of things, and it doesn't allow you to have this interactivity as you find more things, as you go, oh, I need this data feed, and I need some AWS logs, and I need some source code, and I need this, and I need that. So in a way, like that question of how does this work gets very complex very fast because systems are connecting to each other, right? I think now, if we move some of that analysis to prompts and some of that putting things together to an LLM, what you have is the technology is almost the one that gets the data and the one that wires up these questions, but we introduce a layer of almost business logic that is the LLM, and that is the prompts. And what that allows you to do is allows to say, I got this data feed here, which almost it doesn't really matter how formatted it is. It doesn't matter that if in AWS is this structure, in Azure is this structure, and GCP is this structure, and internally is that one, and here I only have a screenshot of it. The LLMs have the ability to normalize that into a common sort of representation, right? And I think that's where you can then start to build tools on top of it, where a chunk of the tool and a chunk of I would say that engine of how do I discover how that works becomes sort of much more moldable, right? In a way, it's a lot more of a moldable environment because a chunk of it is now a prompt.
I think that's a really interesting approach. And certainly, it's good to see different ideas around how to address that specific technical challenge of diverse data sources and different formats and so on. But just to take it back to one of the points made earlier, I think sometimes in a discipline like security, we sometimes think we are the first to do something. How do we scale security? Well, actually, if we kind of think about other things that organizations and groups of people have been doing for either decades or even hundreds of years. So, for example, controlling money in an organization is something that's been happening for a lot longer than information security. Yeah. So where is the money? Who's in charge of it? Where did it go? How much was spent on this particular project? So we can learn from that and say, well, maybe there's some interesting ideas there around we hold some people accountable locally. So you federate responsibility. We audit, and we kind of log how much we spend. So the practice from kind of financial accounting has informed some of the ideas in information security. And in the same way, there's there's new discussions around the safety and kind of risks around the use of AI. I always say to people, this is not the first time we've done this. We've asked the same questions in other disciplines. So one of the special things, as around kind of these new techniques around AI is that they're kind of sometimes indeterminate, sometimes you can have answers which you can't predict easily. There's sometimes a black box, unexplainability. But it's not the only industry that's happened in. So if you look at, say, pharmaceuticals, drugs don't work the same way for everyone all the time, but we've developed over decades methods by which we can achieve assurance and satisfy ourselves that this is a safe thing to do within defined risk boundaries. And the same idea can apply in here. So I think it's a good thing to look at other sectors, whether it's civil engineering or pharmaceuticals or financial accounting, and say, is there a parallel problem there that we can bring back to the work we do here?
Well, one of the things you mentioned, which I think is key, is that one of the best data points to mapping the attack surface is the accounts payable list. Literally, you go to the finance. One of my party tricks is go to the finance team. You want to map shadow IT? Ask the finance team, who are they paying? And then you realize that as part of the organization don't even know. But here's the interesting thing, right? So, and I want to distinguish, when I talk about Gen AI, I'm only really talking about processing data. I'm not talking about creating data. So what I'm saying is that now with Gen AI, I can take 5 outputs from 5 different finance systems, right? Which are all freaking different. And none of them were designed to be sharing, which is part of the problem. But I can now take outputs from almost whatever they can give you, right? You can feed that to an LLM and say, now extract the attack surface from here, right? That's a game changer, right? Because in the past, you had to build a connector with every single one of these tools. Now it's more about just freaking get the data out, even if it's on a CSV, even if it's just screenshots, right, of a UI, right? As long as you can get something out of it, you can now do the translation, right? And the attack surface, right? Again, like you said, a lot of other teams have figured this out. What we never been able to was to consume the data from them. And then once we have that, explain it back to them, right, in their language.
Yeah, absolutely. Absolutely. It's interesting. One of a large organization that I worked with recently, we did just that approach. So a traditional audit around data and technology, and we introduced this idea of a third triangulation point to say, actually, what are we paying for? What money's going out? And as you suggested, that's a great way of identifying shadow technology and kind of undeclared services and other kind of information flows. So really interesting idea.
And going to Chris's point, right? Which by the way, Chris, the way I read it is that the more you can personalize, right, the more you can make it relevant to the individual, the more they make sense. So I had the exact same experience where when we wanted to do awareness programs, we realized that it was much better, even at the top level awareness, to teach them how to do cybersecurity themselves personally for their kids, for their stuff. And then there was an anchor there. There was an anchor that said, look, see, the same way that you now care about your kids' privacy, this is now the connection to the business, right? So and again, that personalization in context, even in culture, right? Like, remember that as we cross multiple teams and countries and cultures and everything, you almost, the same message for a Portuguese is actually very different. I'm Portuguese, by the way. For a Swedish and an American and an Angolan and somebody from Australia and somebody from other sides of the planet, and different cultures have different sensitivities, right? And they care about different things. So I feel that, Chris, your point of you need to customize to the audience is the best way to drive whatever message we then want to drive.
I think one of the things that clearly, the use of these kind of technologies, data summarization technologies, is potentially really, really powerful. But some people, including myself, will always ask, what about the cases where it doesn't work so well, or it gets it wrong, or what kind of data input is it really strong at? And which kind of data is it bad at? And we don't always know that up front. So I think then the discussion changes into, do we care? If we're not doing this before, and this is 80-90% accurate, let's say, that's a huge step forward, is it? Or or are we in a different scenario where if we miss the 10% and that doesn't end up on the summary to the board member, does that mean we kind of, end up in court, So I think it raises different questions, and they're necessary. So some people have a natural kind of fear or distrust or of these technologies, or they think it's overhyped and so on. But I think actually the right response is to say, is this going to improve what we do, and do we understand what the impact of it failing is? Yeah, I think that's kind of a better questions, I think.
So I love the point about the failure, right? Because again, in the research, we found an example of a company which produced TNT explosives, and it was before the let's say very close to me conflict. And that at that time, the company was actually believed to be non-critical, because who would like to hack this kind of a company, given that their product was heavily regulated? It was used for mining purposes, right? And heavily regulated, you couldn't buy it, very limited set of buyers. Nobody really cares about what they are. I mean, nobody really, it's not useful for anyone. But suddenly, because of the conflict, their risk profile completely changed. Every system that they had suddenly became critical, because you could destroy, I mean, you could stop the production of explosives, you could track all of their customers and actually anticipate what will be produced against you. You could discover people who were engaged in all sorts of the value chain and use any sort of extortion against them to get into that company. And this happened nearly overnight. This sort of the change going from low risk company to high risk company. And the worst bit was that during the pandemic, they have shifted to remote work in the simplest possible way. They have enabled remote desktops. Exactly. And now, how do you deal with that stuff, right? Because if let's say, it is an extreme example, but you can easily imagine that if you run a company, I mean, Dinis, with the cybersecurity board, you will have, for example, access to many, let's say, very confidential sources of data. Suddenly, you are a high-profile customer. I mean, high-profile target, right? And you need to apply completely different measures to the security than any of your customers.
But I'm trying to design that, right? And actually, you just mentioned a very interesting topic, which I think is worth exploring. And Tudor, can you expand on this? Which is the concept of context, right? Because what you talk about was to say, I have these environments, and it's kind of like, when Tudor talks about we need to map the attack surface and we need to understand how systems works. It's almost, that's just the beginning, because you then need to have context to understand what's important, what's not important, and then we can design things in a certain way. Like, for example, the way I'm trying to address that problem, with the cyber boardroom is, I'm not going to solve that problem. I'm basically going to say, if you want security, here is the AMI, here is the tools to run it locally. But I had to engineer that in. Do you know what I mean? I had to develop a product so that I don't have one copy of it running in the cloud. I have N copies, and any potential customer can have it. Right. And but I think that this concept of context is I think super critical. Like, when in Tudor, the things you talk about, right? Like, context is in a way almost changing, right? So you need that flexibility, because what's important today is not going to be important tomorrow. What's important here is not important over there.
Indeed, yeah. So context is, software is highly contextual. And especially if you then add the software system in a socioeconomic environment, then the context explodes even more. So when something is highly contextual, it means that you can predict classes of problems, but you can't predict specific problems. If you can't predict specific problems, you cannot produce ready-made solutions, right? So, Tariq, right, you were mentioning bespoke solutions, right? That there needs to be a balance between bespoke solutions to bespoke problems and some sort of general policy. I think today we favor the general policy too much, because we don't know how to deal with bespoke problems at scale. And the reason we don't know how to do it is that the cost of tools is too large. Of course, you need tools to deal with any sort of data. But then the question is, what kind of tools, right? So given that you can't predict the specific problems people will have, it means that the tools have to be created after you know the problem. So it's part of the development. So you can't just build the system, you have to build the tools and the system. And so, but now, of course, then the tools, we're talking about orders of magnitude cheaper tools. not a little bit. It's not an increment. It's fundamentally different kinds of tools.
Yeah.
So then back to your points, Dinis. Like it's so expensive to go and reason about the different kinds of data sources. It's true, except that we don't know how cheap it can be. Now, there's also another thing. So I think before we go to Gen AI, it's possible to build tools that are many times cheaper than what we understand as tools today. We have done those in practice over the last 15 years. And we deal with every single development problem, not just large problems, like the tiniest bug, sometimes dozens of times per day, per developer. We're going to build custom tools.
Yep.
So we will have thousands of tools per system.
Yep.
And that's a completely different world. But now, of course, generative AI does have a does have a role to play. I do believe that. And but I think there's a very large distinction between saying, giving data to the generative AI and say, give me, for example, what's the surface attack area? Because everything that one versus getting the same data to the generative AI and then say, please propose a tool that detects the surface attack area. These things are completely different.
Yeah.
They're very, very similar, fundamentally different. The reason why is that the first one, so when I ask, tell me what the problem is that I will always get generative AI in the current form. There are always going to be opinions, which are very, very interesting. I don't think it's particularly useful. The truth is, that's going to be particularly interesting to find alternative perspectives that you're not aware of. That's what you do, for example, when you brainstorm. But it's for sure, anything that comes out of it is much more interesting to look at it as an opinion, as a hypothesis, something that you want to go and check. But if you just get the hypothesis, but without the possibility to check it, not so interesting. On the other hand, if you get a hypothesis in an executable form, so here's a tool that you can go and try. Here's a tool that you can go and look at. And if the tool is actually not that expensive to build and maybe not that large, then you can actually make sense of it and then try it against the real data. And maybe you can go in and adjust and then have a conversation around that. That is the game changer. That's what I think generative AI has a very, very interesting role to play.
And you know what? The one that I really liked that described that really well was this engineer, the CTO, I think CTO from Figma, the guys who do the UI and HTML. And they were saying that they tried to use Gen AI to create HTML, right, from a picture, right? But he had this very interesting nugget, which for me which goes straight to the heart of what you just described to there, which is, in a way, the most way to execute something in a way that is deterministic is code, right? If you think about it, code is actually the most deterministic way. So in a way, what I like to, and some of the practice I'm doing is you might even start with a Gen AI first because you want the art of the possible. But then the logic is you start with smaller and smaller and smaller Gen AIs once you know the pattern. And ideally, the pattern that you should be following is the one you described, which is you start to create tools that give you the same input and output with code. So using that analogy, let's say I have this massive dump from the financial system and I want to map the attack surface. You could say, right, multiple LLMs. Okay, cool. I now need a tool to parse this, right, in order that I can get these outputs. So in a way, you will end up with human-owned and highly verifiable code and content. But for me, the key part here is that until the Gen AIs, it was impossible to do this because you couldn't scale this, right? Where now, what's cool about it, even on that example, you could say, and I know, but not everybody has your toolkit and your capabilities, right? You guys did parts of it, right? But I feel that we now have an ability to say, even to modify, look, here's another data feed. How can I modify this code or this mini tool or this tool of tools so that I can now consume this data feed so can I achieve the output, right? And those relationships in the past were really hard to visualize, where now I think we're going to get much better architecture diagrams, much better flow diagrams, much better documentation, much better, understanding of how things work, because we can actually use the LLMs to map a lot of it. But I really like your concept there, is that ultimately creating a tool or creating highly verifiable code, right, is in a way you evolve that is the best possible outcome, right?
Yeah,
'Cause
well, so go ahead,
No,
Chris.
please go on. Please go on. Well,
So I was just saying, so that you mentioned like, like before the tools are expensive, tools are not, we don't know. Like we know we've practiced the way of programming where we are building a ridiculous amount of tools. And we are many times more productive than whenever we're comparing with anything in practice. This is something that there's no magic here. It's literally an engineering practice we think is quite important in software engineering. And so I don't think there's any replacement for that. It doesn't matter who creates the tool. It's much more interesting. It's who wants the tool and who understands what the tool does and what the trade-offs are. Because before you're going to use a tool, you need to go and really understand what that is. And sometimes you might not exactly know how to put it together, but you still need to know what you want from that tool. And you want to know when the proposed tool is slightly different than the semantics that you were looking for. Because the mapping of the context to the tool is kind of important. Now, there's another point, right, that you mentioned, Dinis, right, that the tool is reproducible. It produces a reproducible execution. Now, one way to look at software is to say, well, here's the input, here's the output. Another way to look at software is that it encodes knowledge. Right. So, for example, in a system, right, most systems have replaced somebody's manual work. Yeah. So we used to call those people knowledge workers, and now you have a system. Therefore, the system encodes that knowledge. Now, when you look at the system as encoding knowledge, it's very, very interesting to actually extract the knowledge out of it and go and reason about this. Now, interesting enough, you can use a tool. That's unique in software because you can use the same thing to reason about the thing that we're reasoning about. But the key there is that the tool is also knowledge encoding.
Yep.
And so the tool is not only, sometimes it can be disposable, but that doesn't matter. What matters is you need to understand what the knowledge encoding the tool is before you can actually manipulate the tool in any meaningful way. And this is really, really fine-grained. And this is why asking for a diagram and you get the diagram back from the LLM, absolutely meaningless. It's just somebody's opinion. And there are plenty of diagrams. So whenever we go into an organization, they don't lack diagrams. It's just that all diagrams are wrong. That's the problem, right? So people are just going around and making decisions on absolutely wrong information. Yeah. And then, of course, the information is not going to be. But so those diagrams, they document. Anytime somebody draws something by hand, the diagram documents the belief of the author about the system. It doesn't document the system. So you have to be very careful. Sometimes the beliefs are really important, especially for the future. You want to guide the future based on some wishes you express today. But about the present, you should never be deciding based on belief, right? So the present should never be a question. So what this means is that when I'm going to an LLM, I have exactly the same thing. I get the picture back, but it's just an opinion. It's not particularly meaningful for decision making. You need to know what knowledge has been encoded in it, how was it encoded, and then you can go and interpret it. And that's why it's not the picture. It's the tool with which you're going to build the picture that is more interesting for us as humans.
Chris, I think you're gonna.
Yeah, so I just wanted. Apologies, I don't have this at hand, but I remember looking at research showing that tooling isn't, to some extent, tooling isn't the problem because the majority of tools are misconfigured in the, let's say, corporate environment. And even if they are configured properly, the majority of others that they raise, they are ignored because there is nobody that can look at them.
No.
And,
but the way Tudor is approaching it, if I'm not wrong, but is that we need tools to understand the complexity, right? We need tools to understand the attack surface, right? It's too much data, too much complex, right? What we need is customized tools, right? That actually work, right? In fact, we need tools to understand what the other tools are doing, just even to confirm that they're mostly configured. In fact, even to configure them nicely, we need tools, right? Sorry, go ahead.
I mean, I get it, but it is. I'm trying to make sense out of it, because I do understand everything. I think I do understand what Tudor said in terms of the complexity and tools and beliefs and stuff like that. But there's this. So this is all very nice, but then there is this reality where people don't have time to even look at what existing basic tools which scan, let's say, available infrastructure for very basic misconfiguration items, what they do, right?
But that's because the concept of tool there is very narrow, right? Like, so one of the things that, especially when you're in a position of responsibility, right? Like you, as a CISO, you shift very quickly to, this is bad, to what can I do about it? How can I fix it, right? So to have a tool that just tells me that this is bad, first of all, it's only a piece of the puzzle, and I got a whole pile of them, right? What you need is an integrated tool end to end, right? Like, in a way, the objective here is to reduce the attack surface. So the tool should be focused on reducing the attack surface, right? Where getting a signal is just one part of it, right? In fact, it's an important one, because when you do a fix, you should make sure the fix actually works, right? But I think we need to expand the definition of tool, right? Because in a way, a tool is something that helps you to achieve X, right? And in some case, X is to reduce the attack surface, right? So you have to cover the whole chain, right? It's not just, I have a vulnerability scanner here, I have this bit here, I have that there. It's like, how do you integrate end to end from here's the problem, here's the description, here's the ticket in the backlog, here's the scheduling, here's the people doing it, here's how I test it. All of that has to be a tool, right? And that's why, the moldable development, I think that Tudor talks to is spot on, because if you cannot speak on every one of these layers and every one of these things, you just introduce some attrition, and then that doesn't scale, right? And you need to have these end-to-end flows, right? To so that you even understand why we're fixing it, right? And that's why context matters, because you then go to the point and says, well, I don't care about these ones. Woo, I really care about those over there, right?
Yeah.
Because the thing about those tools that you can easily run, right? Available out of the box, very, very appealing, run on any system. How many false positives do you get out of them? Right? And that's the reason why people don't look at it. Like, for example, you see similar things. So I give you static analysis tools, right? Static analysis is very interesting as a technology. It's known, nothing new there. So you can get all sorts of information out of the system. So people are using static analysis, except that they have thousands of warnings in their system. Why? Or they have very few rules. One of those. Why is this? Because this is kind of interesting. You say, oh, maybe they don't care about quality. But then you look at their tests, and their tests are all green, no red. How come? Why is it like, how is it possible that one is full of yellows and whatever, and the other one is completely green? It's the same person looking at both of them. So why? The difference is that a test is never downloaded from the web. A test is always constructed within the context of the system. So a test encodes somebody's value, some part of the system's value. The thing that comes from the web encodes somebody else's value, which is not particularly interesting for me. And that's it, right? Is when context is important, you have to optimize for context, not for the tool, right? It's just so happened that for the long time, tools were expensive to build, so we needed economy of scale, build it once, run it 1,000 times. But now, what if tools are very, very cheap to build? Sometimes minutes cheap to build. Then all of a sudden, it means I can take a problem, build a tool just for this, run it once, and it's still many times more profitable than doing the check manual.
Yeah.
That's a completely different economic model than that.
And that's, going back to our favorite Wardley Maps topic, right? What we're doing there is we are productizing, right? The creation of tools, right? We are commoditizing the creation of tools for that. But that means that pipeline has to be very mature, right? And I have to say, I found it quite astonished how in 2024, I actually had to spend a significant amount of my time as, a developer, right? Building pipelines infrastructure, right? Like, it's still very broken, right? Like, just to get something that I could press here, ship here, and have it deployed into customized containers in servers, that bit of technology is still not there. Because if you think about it, Tudor, the other thing I would say is that we need those mini tools, but every one of those mini tools has to have a high degree of engineering, right? It has to have a CI pipeline. It has to have tests. It has to be resilient. It has to be easy to deploy. It has to run in environments, right? So in a way, we need that creation of that tooling to be almost productized. So you just focus on the intent, right? And I agree that that's the objective. The objective is the way you map an attack surface, for example, is you literally start to go to every part of your attack surface and you create a tool for it, right? You create a way to extract that data into a common environment so that you have a unique way of, a common way of representing what is what, but also more importantly, you have a way to verify it. Because remember that, it's not good enough to just identify the attack surface. You have to be able to do it continuously so that when you fix something or when you think you fix something, right, you plug that in. And more importantly, you understand the blast radius. Because here's the other problem. Like most companies or most individuals don't want to make changes. It's not because they don't want to. It's just either they've been burnt in the past or they don't understand it. And they don't know the side effects of, flicking this knob or turning that thing off. Because last time they did that, they blew up half the company on the other side, right? So unless we understand the blast radius of those changes, right, people are very, very, correctly skeptical of making changes. And that's why those reds keep existing, because it's not good enough to say, this is really bad. You have to go, dude, that is connected over there, right? That's why. That's the context.
Yeah. Sometimes I find it, and I think today's discussion, which we're encouraging ourselves to think in terms of the mapping approach and thinking about kind of trends and the direction of movement of technology and what is now becoming more possible that wasn't. Sometimes I think it's useful to kind of put on your sci-fi writer's hat and think, okay, in 10 years' time, in 20 years' time, what would be, what can we imagine this technology can do for us? And some of this discussion has, I think, quite rightly taken the discussion above, the nuts and bolts of infrastructure and monitoring and detecting kind of, attempts at infiltration and so on, to the kind of further up the pyramid and grappling with questions such as, what is the business trying to do? What is it trying to protect? What does it mean for us to get on with our work? And then, in order to answer, once you've kind of able to elaborate those, you can then ask, you can then move on to questions of proportionality and cost and say, yes, we have infrastructure which has an attack surface. Can we tolerate certain events? Because it doesn't really matter. It's too expensive to. It's not worth kind of preventing them or investing in them. And that kind of automated reasoning, I think we're not quite there yet. I think some of the ideas you've mentioned, Dinis, around some of the work you're doing in your startup takes us in that direction. But I think if I put my sci-fi hat on and say, what would magic be like in 10 years' time? It would be being able to express two, tools that manage other tools, to say, this is what my business does. These are the assets. These are the people. This is a description of the context. Go discover, go verify, establish automated monitoring, react if you need to changing environments, but also keep me informed of, new trends in the attack kind of space, and also keep me informed of things that are happening, but that don't affect my business. I think that at the moment is all in the hands of humans today, so it's not that scalable. But if something could maybe not fully automate, but aid a human who is accountable, I think that would be really nice. And as you say, for all the reasons we've discussed, it doesn't happen today because it's just a lot of work and all the issues around. When I say something, somebody else interprets that differently because of kind of cultural reasons and business reasons and so on. I think it's just sometimes useful to think, where would we like this technology to end up in 5 years' time? I don't know if you've got different thoughts. Do you think?
Absolutely. And to that, this is where I want to disagree a little bit with you, is I think security and cybersecurity is different because we are the only team that in a non-political way has access to everybody, has access to all the data. When we do the job right, we have relationships with everybody, and we have almost an automotive to do the right thing, right? Because we tend to be driven by a customer, by something bigger than a particular unit. So yes, I think there's a lot of parts of the business that could drive this, but I think cybersecurity is one of the few that is really, it's not the only one that's proper horizontal. and vertical at the same time. And and I think that, for example, when you look at the data feeds, the data transformation, the relationships, connecting that entire food chain, we actually can have relationships with every single element in there, even when they themselves don't have those relationships, right? Most businesses don't even know how they work, right? In fact, if we tell them, they're going, wow, that's great. And I like Tudor when you were saying that business should be making decisions today about facts, right? Not about future stuff. But very few businesses actually understand how they actually work, right?
Yeah,
Absolutely.
Well, I just wanted to say that I'm not saying that the discipline of cybersecurity is not different. It is different for sure. I was just saying that the act of asking a system for a question, for an answer, is going to be very similar. It's not specific necessarily to this, but yeah, the human parts are of course going to be quite different. Now, Tariq, also just to add to your set of wishes, if you can just say, once you do all of that thing and deploy the system and make sure that it's doing precisely everything, if we can just ask the LLM to say, could you also make the system do money for me? It would be great.
Yeah.
All right, guys, we're going to actually, sorry, on this topic, Chris, any comments on this area?
No, everything has been said.
Yeah, well, as a consultant, a lot of times don't you find that your job is just to understand how the system works and then explain it back to them, right? But that was always my frustration. I remember doing assessments or even analysis where in the end I realized I know more about how that system works than they. It's not because we're more intelligent, or it's just because we're asking better questions and because we are aligned to understand. Where it's amazing how few people in the business actually stop and think how it actually works, right? And I always find that sometimes even when you deliver something or a report, or it's almost a photograph of what we know, but actually we knew so much more, right? So I actually think that we can now scale a lot more that knowledge transfer of these individuals that are able to come in, understand how it works, and then you almost give you a three-dimensional, sort of something that can be consumed not just as an initial photograph, but as something much bigger than that.
Just as a complement to that, whenever you come from the outside and then within a short amount of time, you can tell new things that the team that worked on it for maybe a decade, let's say, doesn't know, right? So you tell them new things that they didn't know about their own system. But what it says is this, it's not so much about the skill of the person coming from the outside, but just simply says, given this is such a common practice, such a common situation that people working on their system eventually end up not knowing what the system is. It simply describes how poor the baseline in our industry is, right? There's so much potential. Like, what would happen if the business would know, would have answers about their own systems all the time and accurately, right? We should not be able to have orders of magnitude difference. So when you go in and say, let's see, in a couple of months, you sell them something new, and then you compare maybe a couple of months of effort with 100 years of effort. You shouldn't be in a position to tell them something new. It's not reasonable. It's orders of magnitude. So if this is still, as long as that is possible, it simply says that we don't understand, or the industry doesn't understand the industry yet. So that's what I would be worrying about today. If I would be in a position to.
But a lot of people are finding that. They're finding that, yes, you can automate a lot of stuff, but the core data is not there, right? The core understanding is not there. So you operating with shadows, right? And actually you need to fix that. Doesn't sound as glamorous, but actually those are the key tenets that without that good data mappings, that good understanding, that tooling from the bottom up, there's only so much you can do.
I think on that point, from a slightly different perspective, so not necessarily kind of doing security work, but doing kind of architecture work, the same situation, you come in as a fresh pair of eyes and you tell them things about their own business and their own systems that they don't know. And I think my experience is that, lots of organizations are quite successful financially, commercially, not knowing. So there's no real incentive to change what they already do. And it's only when something happens that they feel that the global good has trumped the local good. So the local good being, I know my system. I'm just going to get on with selling widgets, or this process, or this this kind of part of the business. And as that's so the argument then has to be made. Why do we have to put some effort and investment into the global good, knowing how it all fits together? What is the risk that you don't know you have, or what is the cost that you're kind of incurring that you don't know you have? And sometimes I wonder if that's kind of those arguments translate into kind of the cybersecurity world, where you say to an organization that seems to be successful, doing okay, generating profits, nobody knows how the organization works as a whole. Everyone knows their own bit. What's the argument to say you should have people who are paid to inform the chain of command and everyone else actually? This is actually what your organization is. This is your data. This is your risk. These are your information flows. These are your processes. And sometimes that's not easy in my experience. I find because it's not broken. So why fix it? I don't know if you've got any different experiences on that. It'd be good to hear different views.
I can share
I think the reason. Oh, go ahead,
go. Please go.
I was just going to say that the reason for this is because the baseline is so bad. Like, your competition is also as blind as you are. So if you have a better stick to find your way and poke, your way, then all of a sudden that's the thing, right? But then as soon as somebody starts to see, everybody will have to start to see. Today, people don't know how to see. That's the problem. So we're perfectly fine with not knowing how our systems work. It's ridiculous.
So I can share something slightly different, because we also did the research on tech debt, and one of the findings was that every business operates on the scale between adaptability and efficiency. And in the recent year, adaptability and efficiency, because adaptability costs money, right? It's a redundant skill. And what I think we actually experience is that organizations are striving to be so efficient that they have let go the ability to actually understand how they are operating. Each time when you need to do a change to the organization, you actually have to hire external consultants, because nobody inside has the capacity, not mental one, but time capacity, to actually do and investigate stuff. How does it work? So you need to bring external consultants whose only job is to go through your systems and try to reverse engineer of how this stuff works. It's kind of unfortunate, but very reasonable way of looking at the space. Yeah?
But that's a really bad, I think, economic model. That I think we got away with it for a while, but I think more and more, I think the difference is because of the competition now gets much faster and much more effective, you don't have those times to do it. And I think in the past, companies got away with the mistake of letting, for example, people go that might not seem crazy important, but they were the ones that really knew how it worked, right? So they were almost like amazing pieces of the puzzle, but nobody knew that they were. And then, when they left, or when they got fired, or when they were allowed to leave, nobody went like, oh, we need to, we should do something about it, right? Because again, the reward systems are wrong, right? The reward system should be based on the value and the knowledge of somebody, not whatever job title they have, right? And this is, again, what I like, the idea of tools to tools. And like, for example, attack surface mapping is also about understanding where is your attack surface, right? And sometimes I can argue that those two individuals, if they leave, they dramatically increase your attack surface, because they are the ones that actually knew how to fix something. They're the ones who actually knew how a system worked. So your attack surface can grow spectacularly, because you went from being able to react to not be able to react, right? And that's a key part of the puzzle, right? Which, again, I feel that we now are going to start to be able to understand, because we can connect the dots. And to going to your point, I think in the past, companies got away with a lot because of the speed and because of the sort of the moats that each industry had, right? I like even static analysis, for example, Tudor, like, I think a lot of the security static analysis, if they don't get their act together, they're going to be destroyed by the QA static analysis, right? Even by a risk tool, right? A risk tool that is proper LLM enabled, that really understands the code, will give you better static analysis than the static analysis, because the risk tool will be able to say, this is the code that you need to do to address that risk, right? Don't worry about the rest, because or else you get the static analysis, like you said, spewing out all this stuff that have no risk context, right? So I think now we get a speed that, even if, to Rick, your point, even if a part of the business is operating nicely, they really need to go to that adaptability that I think Chris was mentioning, not just efficiency, because we now start to measure the real costs of efficiency. So,
I
right,
think
guys,
that point.
we're right on time. Any final thoughts on this? On on the sort of attack surface mapping and how we can scale it and understand the business. Maybe again, Chris, start with you, and then.
No, I just wanted to thank you for having me here.
It's cool. It's always a great conversation, right? Tudor, any final comments?
Well, yeah, thank you. I think this is a really interesting area, and in fact, I think the whole landscape changes today. So a couple of months ago, there was a really interesting report coming from the White House regarding security, and they considered they clearly stated that security is a critical ability or strategic ability for the next couple of decades. And what's interesting in that line, so they were talking about some languages which are better than the other languages. Maybe that's debatable. But at the end of that document, the second part of it was really, really interesting, especially the last part, which said that in that new world in which security is such a critical skill, it's the board responsibility to know what their systems are doing. That's going to be a completely different world.
Yeah. Well, I'm doing a startup trying to explain that to the board members, right? So they actually know what the hell they're doing, right? And it's interesting that there is now a pull from board members, right? Because they start to see that coming. They could see that the board members have to start to be responsible, right? They cannot have plausible deniability, right? And that's, again, that's the driver, which I think is good, right? Because you do need accountability right at the top, right? On this. Tariq, any?
Yeah, I think just following on both of your points, I think we're at that point now in this discipline, this profession, where people are now starting to think about how do we aid and maybe automate partially those questions that are further up the pyramid, as you say. So we've done now monitoring networks and doing alerts and all that kind of stuff. Now it's a question around how do we describe the context? How do we automate or kind of machinize descriptions of what isn't acceptable in the business? And then with a view to further kind of interacting with, as you say, a board that is increasingly finding itself responsible and accountable. So I think that's a really interesting point in the history of this discipline. And it'd be exciting to see what kinds of tools and techniques and methods the market kind of comes up with in the coming years. Honestly, I found the old stuff not that interesting. Network monitoring is a thing, but it's not that interesting. But these questions of how to bring that data together, how to distill it into something that hopefully encodes organizational knowledge, something about the context, something about the kind of risk appetite, and how that kind of, if it is at all possible, in a more automated way, present that to business decision makers. I think that's a really interesting space to watch.
Yeah, and so I think final point for me, I think this is a very exciting time because I think for the first time I can see how we can do that at scale, right? I think you can connect those dots, right, with the business and make it really relevant to the business, which are making the decisions on this. So still a lot to do, but I think now we can scale into this world. Great, thanks a lot for your time. This was a great session. We're going to create some nice segments of this and then see how it goes. Brilliant.
Fantastic.